Well, hello and welcome to another DevNation Live Tech Talk. I'm excited to be with all you guys today. We're going to be having a lot of fun talking about Ansible. And you know it's Ansible awesome. It's going to be awesome for all of us here right now. And what we're going to be doing is we're going to be going over to Adam Miller. He is our expert. He is the guy who can show us how to make Ansible awesome happen. And not more importantly, he's going to kind of live code, show us a bunch of amazing demos. It is going to be super cool. Now, if you're not familiar with what we do with Tech Talks, be sure to watch out for our weekly email that comes out every Thursday. Normally it comes from me, and therefore, if you block my emails, you won't actually see them. But you should get that email that'll tells you what's happening today and what's happening for the next 7 days. And if you saw today's email, you saw that we're doing Quarkus next week, along with another Istio session, and there's more talks up and coming. I will drop the links to the upcoming schedule into the chat, but make sure that if you guys have questions and thoughts, throw them in the I'll be monitoring that, and then we'll get them to Adam verbally as he kind of wraps up his presentation. But at this point, without further ado, I'd like to turn it over to Adam and let him introduce himself. He's got a very awesome introduction. Adam?
Hey, thanks, Burr. My name's Adam Miller. I have the unique privilege to work on the Ansible engineering team at Red Hat. I'm a big fan of open source and working upstream, and I've documented my personal open source journey on my person. So I have my Red Hat Shadowman and my Ansible tattoo. That's my interesting factoid about myself. So one thing I want to go ahead and do is quickly show a few slides just to do a introduction and hopefully a quick recap for those of you watching today about what Ansible is. And just a level set, a few vocabulary terms, so we're good to go. So let me get that shared here. Okay. Or can you confirm that we have slides?
Yep, looks great.
Okay, great. So just very quickly, Ansible is an automation tool. Ansible at its core is a simple, agentless, idempotent task automation tool. That distinction because people who will approach Ansible will generally look at it from either a configuration management use case or a DevOps work practitioner use case, but don't necessarily fully encompass its full capabilities. And the reason I make that distinction is because we can command and control all sorts of physical hardware devices, networking, firewalls. We can integrate with various security products, SIEM platforms, intrusion detection, as well as all of your typical Linux and Windows automation system administration needs. And then we can also do provisioning. We can do bare metal provisioning. We can do cloud virtual machine provisioning. We can do all sorts of different resource provisioning. So the Venn diagram of everything that is automation and that Ansible is capable of, if we were to take that, we can put inside of that a sum of automation tasks that could equal configuration management. But do realize, and I hope that today one of the things that we go through and highlight is that Ansible is capable of much more than that. So we are a task, in-order task execution utility out of the box. The in-order can be changed, but typically don't. Tasks are performed via modules. So you'll notice me mention the term module. Modules are what defines the action a task can take. Tasks are grouped together via a play. So a play is a thing that lets us define kind of a unit of automation. And then you can have sets of tasks be put inside of a role, and roles are reusable units of automation that you then will pass variables into, and it will be templatized and things like that, and we'll briefly cover some of that as well. Playbooks. A playbook is a thing that Ansible honors the first-class citizen. A playbook is a YAML file that Ansible will run through and execute all of the plays. A play defines a set of automation tasks with a set of inventory hosts, and we'll talk about the inventory in a minute. And then we also play nicely with many other things. Our unofficial motto is Ansible plays well with others. And one of the things that we often see is Ansible versus some other system, and we like to mention that they don't have to supplement, they don't have to replace one another. They can supplement one another. So Here's a very quick introduction of how you would potentially install a package on a Red Hat Enterprise Linux system using Ansible, just against your local host, just to get your feet wet. Ansible localhost is going to be your host pattern. So in this case, it's just localhost. Your module is yum, so M for module yum, and then A for arguments. So the name of the package that we want yum to install is bash. The state that we want that package is installed. We'll run that. Hope bash is installed, because if you have somehow find yourself on a Red Hat Enterprise Linux system that does not have a bash package installed, something went sideways. So if we were to take that ad hoc command, that one simple command, and we were to switch it into a playbook such that it was reusable and it could be combined with other orders of operation, this is what it would look like. So you have playbook.yaml, your 3 dashes to define this YAML file, and then we have our host pattern, which we just had with the ad hoc command, our task, and then our set of tasks. And then we define yum. Yum is going to be the module, and again, the arguments will follow. That's what that would look like. So I like to propose that Ansible can do everything, but it doesn't actually have to. It's not a all or nothing. You can pick and choose how much you want to dive in, how much you don't want to, but do understand that Ansible is capable of doing anything that you can imagine in terms of executing tasks, orchestrate complex order of operations, and then we also offer the ability to write custom modules for custom functionality that you may need in any programming language with JSON support. We natively support Python for all Linux and Unix style platforms, and we provide a lot of helper functions for people who are writing their own content. And then if you're working with Windows, we do PowerShell. We try to keep it as native as possible for the target platform. So the question is, what are you trying to accomplish that can be automated? Well, typically these things, one of these things falls into the category of bullet points here is you have some set of tasks in your IT organization or DevOps workflow and your DevSecOps, something that needs to be done that can be done in an automated fashion, so humans are not having to do it over and over again. And we propose that Ansible can be that universal automation language. We can be that infrastructure glue for everything you potentially do. So in the slides, that's the end of my slides here. I have some useful links that I would highly recommend people to check out when we're done and go through the advanced resources. Also, for any reason anybody wants to reach out to me, I try to make myself widely available on the internet. Please feel free to reach out. Let's chat about some stuff. So I'm going to switch over now to a terminal so we can do some coding. All right. Do we have a terminal?
Looks beautiful.
Wonderful. Okay, so I mentioned before that we have this concept of an inventory, and the idea is that you need somewhere for Ansible to know how to reference or access your systems. So we are going to start with an ini file, an ini format inventory. Inventories can exist in many different formats. I will quickly actually switch over and highlight the Ansible doc subcommand. Because Ansible doc can not only reference a module's documentation, so I'd already shown you the yum module in the presentation, so if you do Ansible doc yum, you can go through and see all the documentation for that, and if we jump down to the bottom, you see some examples here, and though you can go through and read those examples and have a general idea of how to utilize that module. Another thing is you can do -L to list, full list, and this will actually paginate using your pager of choice. And then you can also do -T for type, and this will actually look up different types of Ansible plugins. And one of the types of plugins, because Ansible is a heavily plugin-based solution, is inventory plugins. So we have the ability to actually use dynamic inventories. Things we can actually reach out to various sources of truth on your set of hosts that you want to operate on. You can use various metadata tags to target them, things like that. But for ease of use today, we are going to do an ini file. So I also am going to show that we have the ability to define variables that will be inventory wide. So I'm going to set two groups here. I'm going to have what I call container lamp and lamp. We're going to deploy a simple lamp stack for those who are not familiar, because maybe this isn't something you've experienced before, but LAMP is an acronym that became very popular in, I believe, the mid-90s. It's Linux Apache for the Apache HTTP daemon, the HTTP daemon, M for, it was once upon a time just MySQL. Now it can be MySQL, MariaDB, or Mongo. And then P, typically in, the original iteration was PHP, but has been extended to other languages and technologies that start with the letter P. I will, be doing a little bit of Python in my example. But so we can set variables for our group, and I'm going to set my Ansible connection to equal to Podman, because for my containerized simulated local resource, because we're going to manage our systems in a hybrid fashion, my local resource, I'm actually connect over Podman. So this highlights the fact that Ansible has the ability to talk to any native technology over its native protocol, as long as there is a connection plugin. So we will then define the group and our set of hosts. I have a UBI8. For those who are not familiar, the Red Hat Enterprise Linux team has made a universal base image, and the universal base image is freely available. It is built out of the RHEL bits. It's meant for consumption of containers and rebuilding, and also allows you to do certified things. And I don't need to advertise for them too much more, but they've made a great technology, and I'm a big fan of it. So I'm also here going to define for my lamp stack, I'm going to do a SSH common Rs, and this is just turning off, can't type and talk at the same time. So this is going to turn off strict host key checking for my cloud instances that I'm going to provision and go out and talk to. And then I'm going to create an empty group called LAMP, and we are going to auto-populate that group as we're doing deployments of cloud systems. So I'm going to create a playbook called provision EC2. Yeah, that's fine. YAML. Actually, what directory? Just in my home directory. I'll put these in there.
And Adam, there's something just to say. There's a green flash coming from your computer, and I think it's just the lower part of your screen, like where part of your screen is not covering things up, like the slides. Coming from the slides, I think.
I have not. Okay.
So it has. If you're in full screen mode, like in the Vim, I think it was good. But on the terminal.
Interesting. Yeah, I'm not seeing it over here.
No problem at all. It's just entertaining.
Interesting.
What's the green flash?
I have no idea. That's odd. Okay. I'm sorry about that. I don't know. Yeah, I don't know. Okay, so just moving on. I apologize for the green flash, but so we're gonna create a play inside of our playbook called provision instance. And something to note is I'm going to make a couple of different playbooks, but each play inside the playbook could actually be combined into a single playbook, and I'll kind of highlight why I'm doing that different. So we are going to set this to run on localhost, because the way that you interact with the EC2 modules as well as the Azure modules, because we're also going to do a provision in Azure, is to run the code against localhost, and that's going to go out and provision a bunch of stuff in the cloud. So we will do a gather facts no. So another thing to note is we have a facts subsystem that allows you to gather fact information about the machines you're automating. However, because I'm talking directly to EC2 and the information I explicitly need, I will request in my play. I don't actually need to do that. And then we will do our connection local, so that it doesn't attempt to actually reach out over SSH. It will just run the Ansible modules locally. And then I'm going to just set some variables. And the reason I'm doing the vars this way is specifically to highlight the dynamic nature of the tasks themselves. because each one of the tasks that we're going to define will simply use a templatized variable substitution of information we're going to hold here in this set of information. And for sake of brevity, because of time, I'm actually going to grab my variables really quick, and I will walk through what they are. Okay, so for those who are familiar with EC2, when you're going to provision an EC2 instance, you need a handful of things. You need to know what image you're going to spawn. You need to know what architecture, amount of disk space it is, the owner, and all of this actually originates from the Amazon AWS EC2 official documentation. So this query filter that I came up with here, this is also from them. I just kind of borrowed that from their official documentation because it lets me get the latest Red Hat Enterprise Linux 8 image that is available on EC2. We need to define our key pair. We need to define a region, which is going to be where we deploy to, our security group, our VPC, which is our virtual private cloud, the subnet within our VPC, and then the instance name. Now, something to note is you can create these resources on the fly, or you can use them pre-existing. That is entirely up to you and how you want to provide that. And another thing that I will note is as we go through this, there's going to be a lot of things that you will see in the way that we build this has the ability to be molded to different ways that you need to accomplish tasks as an operator. So depending on if you need to create VPCs on the fly, depending on if you need to create subnets on the fly, depending on if you need to create security groups or reuse them, those types of things, we have capability there, and it's entirely up to the end user to prescribe their exact required workflow, and they're there. So really quick, we're going to go through. We need to find the latest RHEL 8 AMI, and anyone who's ever done any type of scripting with EC2, this is kind of a common pattern. So we will use the EC2 AMI info module. We are going to use our region. So something to note here is because in the variable we defined, EC2 info is a dictionary type, or a dict for those of a Python background. We have the ability to subscript it, and we subscript it how Jinja 2, the templating engine, does. Ansible utilizes the Jinja 2 templating engine on the back end, and we have extensive documentation on that. So the owners, EC2 info RHEL 8 owners, filters, filter. Okay, and then we are going to do something a little fancy here, and we're going to register some output here. And what this allows us to do is we register the output of this module, EC2 AMI info, and everything in Ansible talks JSON. It's JSON in, JSON out, JSON over the wire. And the way that we do that what we do is we can then register the output in structured data and allow us to, kind of introspect that information and extract information from that dynamically on the fly. And I'll show an example of that in a minute. So first, we need to resolve our subnet ID, and we will do that EC2 BP subnet filters. Okay, so something to know here is I've used a few different info modules. So Ansible has this concept of info modules, and these are going to be modules that reach out to systems and then literally just provide information. And that is something that we will often find ourselves doing to kind of selectively grab information instead of having to do large queries and then kind of distill that information back on the Ansible side. So that is a semi-common pattern you will find with certain infrastructures and cloud providers, just because of the breadth of information they can provide if you just do a blanket info pull or a fact gathering. So now when you grab the AMI for node provisioning, and we will use something called set fact, which is, for lack of a better, to not get too off in the nuance of it, for lack of a better term, it allows us to grab information from some source in our playbook and then set that as a referenceable host variable or a host fact for our machine. So, oh no, AMI info images. So what I'm using here is actually called a filter. In Jinja, there is a concept of filters. Ansible uses the built-in filters as well as extends them, and this is all documented extensively in the Ansible docs. But I just wanted to mention really quick that the pattern I'm doing here in terms of like having to grab information or just select an attribute from an output, this is a semi-common pattern, especially when you're working with systems that provide you relatively complex data structures back. So we are actually create a security group. We need to create our EC2 instances. So you can create multiple EC2 instances. I'm only creating one at the moment. So our name. Info.instance name. VPC subnet ID. Yeah, that's what I called it. Okay, there it is. Subnets. Something to note about some of these structures is, well, we're not going to go too far into depth about what these structures look like. If you do an Ansible-doc to instance, you can go down here and see role. So the return values. So when you register the output of a module, that information is documented in that module's return value section. So if you're looking at that template of a variable that's subscripted a few times and you're kind of looking at like what on earth is going on there, you can check that in the docs. And I will note that everything in the Ansible doc is also available on docs.com. I just like the command line tool because I'm a fan of it. So we are running out of time, so I'm going to kind of speed this up a little bit here by borrowing something I've already made. Okay, so what I've done here is I filled out the rest of fields that are required to create an EC2 instance. We have our security group, our instance, our image ID, our region. All these things are defined. They're all being provided by variables and templatized. So when you run this playbook, you can actually pass it separate sets of variables that can override what's defined there. If we create a role by default, when you import them, you can do that. You can do the node output. And then we're going to add the instance to inventory. This is not a best practice or a recommended practice. This is just for sake of simplicity. For the example, I'm showing what we can do here. And then using the wait for module, we want to make sure that the SSH service is up and running before we actually do anything. And then we will do Ansible playbook in AWS. And I will note that this is going to run and be super. Nope. Of course, I typoed. Okay, so I pre-provisioned this stuff, so this is going to come back green a whole bunch, except for adding it to the inventory. Of course, I can't type. So, register. Okay, so really quick, we will create a lamp.yaml, which is going to be a playbook that will simulate the installation of a lamp stack. So name, deploy lamp stack. We will do hosts. We will say container lamp and lamp. So we will target host groups. So in our inventory, we define two different host groups. We have our container, which is literally just this podman UBI init I have up and running, and then we'll set our hosts. Our tasks will do name, install packages, yum, name, Python 3, HTTPD, MariaDB server, Python 3 firewall. So Python 3 firewall we need for managing the firewall with the firewall D module. So we will go ahead and start and enable services with the service module, name, and then this will actually show here this item will be populated by the built-in looping functionality. If we say loop, then Ansible will loop over the variables, or the values provided. So I'm basically telling this to start those two services. And then we're going to open firewall ports, D services, so firewall D module, service, permanent, yes, immediate, yes, state enabled, will loop through HTTP and HTTPS. Oh, right. And then also, this example is nice. So Ansible virtualize data. Yeah. So this is a conditional, which means that this particular task will not execute on systems that do not meet the conditional. And you can supply many conditionals, and they can be anded together. But basically, OCI is going to be our Open Container Initiative specification. That's the virtualization type defined for OCI runtime. So on the machine that I'm running, or I'm sorry, the quote-unquote fake machine I'm running as a podman container will not actually set firewall rules because the firewall subsystem isn't running in my container, and we don't need it there. So now we're actually going to quote-unquote deploy some code, which is going to be a bit of a lie for sake of brevity. But let's just say that we have some, super awesome web app, super web app .html, and then we want to say drop that in var www index.html, and then we notify reload HTTP. So the notify marker is for what's called a handler. We want to define our handlers down here. Handlers are also just tasks. So anything that you can do in a playbook or in a play, you can also do as a handler, and then you only conditionally run that one based on if this task here, the deploy some code, actually changes. So Ansible has an idempotent nature. I can rerun this a bunch of times, and the handlers will only trigger if something in the tasks that notify them actually changes. So we will say name, HTTPD, state, reloaded. Okay. And now we will Ansible playbook lamp. And of course. Oh. Okay. Need passive inventory. So one thing I want to really quickly look at, INI, we now have an EC2 system, and then now we can run this with our inventory, .ini, and as mentioned before, as mentioned before, our host pattern here will define container lamp and lamp, which will then hit both container lamp and lamp as our. So the host pattern will look for, the pattern will look for the host group. If a host group is not found, it will then check host names, just as a note. So Ansible playbook lamp .yamp inventory. There we go. So it's going to go out and it's going to do a lamp provisioning both locally on my Podman container, but also on Cloud instance remotely. And something that I did not unfortunately get a chance to because the timing on this didn't pan out as I'd hoped, is go through the steps to actually do a provision of an Azure instance as well, and then add that to the inventory. I will, however, provide that, and I'll put these examples in a GitHub repo, and I will link them after the fact for people to try out and kick the tires on. So with that, while this is running, if there's any questions, I'd love to field them and chat about. Oh, good. Glad.
Well, we do have some questions that we might toss at you, and maybe you can multitask a little bit there. And that is someone noticed like, hey, why not DNF? Why Yum? So I did notice you use Yum there. What is your opinion on DNF versus Yum?
So I am one of the maintainers of that module. The Yum module in Ansible will now work for both Yum or DNF. So when you run Ansible setup a filters mgr, when you run the so our setup module when you run the fact gathering in an Ansible playbook, it will actually go out and gather this information. If you turn fact gathering off, there's actually what's called an action plugin for the Yum module, which will figure out that information for you. So based on the host you're executing against, the Yum module in a task definition will actually pass off to the appropriate backend, whether that is the Yum 3 module or the DNF module. And the reason that is because when Red Hat Enterprise Linux 8 came out, the definition from Red Hat as the operating system vendor, the default system package manager is Yum. They deemed it Yum version 4 with the DNF backend. So the command line utility has a one-to-one CLI compatibility with the old style Yum. You're executing DNF on the DNF libraries on the back end to do all your depth solving and everything. So because Red Hat deemed Yum as the package manager for Red Hat Enterprise Linux 8, we want to make sure to carry that over, because if a user of Red Hat Enterprise Linux is going to use Ansible and they want to do package management, and Red Hat says Yum is what you use for package management, we assume they will kind of extend that and use the Yum module in Ansible. And if the Yum module in Ansible blew on RHEL 8, we would probably have some upset folks. So I actually implemented that. I implemented a action plugin that will figure out what the backend is and pass it appropriate. So if you were to run this on Red Hat Enterprise Linux 7 or 8, or a recent version of Fedora 30, 31, 32, the Yum module will work on all of it and pick the appropriate one.
Is the technique also applicable to systems with system, not systemd? Someone noticed.
Yes.
Okay.
Yes. So similar thing with the service module. So the service module will work for 5init, Upstart, or however, there is a systemd module. So Ansible docs, systemd. There is a systemd specific module to allow some more advanced functionality, things like daemon reload, masking units, that sort of thing. Whereas, the other init systems don't really have a corollary. So the idea is, so for DNF and Yum, it's very easy, because for the breadth of the Yum 3.x functionality, there's a one-to-one mapping. The DNF module will advertise and allow some DNF specific things that extend, that's a superset of the Yum module, whereas the service module in Ansible presents a more limited use case of the type of functions that are available from all of the different init.
And David would like to know, he says, just curious, can we use package instead of Yum?
You can use package instead of Yum. However, package has a limited set of parameters that it will actually pass off to the backend. In the package module does a similar thing that the service module does, where it provides the lowest common denominator set of functionality. So if we look at Ansible doc package, you basically get name, state, and use. So name is going to be a list of packages. The state is present or absent, or I think latest is also supported for upgrading. It's there in the docs. And then package manager use. So if for some reason the auto detection of the package manager on the back end fails, you then have to define what package manager to use anyways. Whereas if you're targeting more advanced use cases, so Ansible doc Yum, so we get things like allow downgrade, auto, bug fix only installs, disabling excludes, dealing with plugins, repos, etc., downloads, install routes, weak dependencies. The list goes on. There's a lot of capability that Yum offers. A lot of system administrators and DevOps practitioner people who want to automate those tasks, they want to do that with Ansible, and we provide that more in-depth capability in the package manager specific module.
Okay. And we are running out of time, and so we kind of need to wrap things up. So thank you so much, by the way, Adam. Awesome job. I love what you did there, because you were willing to go for it and hack things live and break things. I love.
Yeah, and we broke something. I just don't know what.
So there was an interest in the Azure example. Samuel would love to have the Azure example. If you, when you have it, let us know, and we'll make sure we try to get that information communicated out there. Maybe I guess we can add the link to the slide deck, and when we re-upload the slides, people will have it at that main URL. The URL everyone is on right now on the live stream. Samuel had another question though, and he wanted to make sure, double check. In RHEL 8, in CentOS 8, Yum is using DNF under the covers. I think that's what you said, right?
Correct.
Yeah, Yum 4. So yeah, we did get that feedback from customers. I mentioned in the chat. Customers are like, no, you got to keep Yum. Don't switch anything there. We have years of scripts that will need to be.
Oh yeah.
Yeah. Okay. All right. Well, I think at this point we do need to wrap up. Adam, thank you so much for that. It was a fun session. I enjoyed it. Hopefully you had a little fun, a little stress there. We will have to figure out at some point in the future where that green flash is coming from. It's like. Yeah. What it is a piece of your slides is still showing on the screen. And so, like right now, it feels like you're not really in screen mode. You're showing a partial screen, and therefore your slide deck is showing through, and it flashes green. That's what we see on our end. It's kind of fun.
Interesting.
Yeah. Well, no worries at all. Any closing words from you for the audience here?
Have fun automating everything you possibly can. It is extremely advantageous for your, personal sanity and enjoyment of your day job. And I say that from experience. I found Ansible and became a fan, and then became an upstream maintainer, and then 4 years later had the opportunity to join the team. It was one of the things that, as a sysadmin, it really gave me the opportunity to stop doing some of the more rudimentary tasks, because its on-ramp is small. The amount of buy-in you have to have is small, because you can just pick and choose very small things to automate and build up from there. It's not a large infrastructure you have to deploy. It's not a huge buy-in of throwing away old tech and jumping on new stuff. Just try it out. Come join the community. Provide us feedback, engage. We'd love to have everyone come get involved and let us know what they're doing.
Yeah, and I think you bring up a great point, Ansible. We actually had it in the chat while you were typing that people were like, well, that sounds like an old PS2 style keyboard. Then we talked about computers from the 80s like NCR. And so you can use Ansible actually for really old equipment cases because of the nature of how it's architected and how it works. Right?
Yes, in fact, we recently, in partnership with IBM, launched AIX functionality and System Z. So we have the ability to do Ansible automation on mainframes and AIX.
Awesome. Well, again, thank you so much, Adam. Thank you all for hanging out with us today. We had at least 200 plus of you, maybe close to 300 of you in the stream live. Do know that this is the URL for the recording. More sessions will be coming. As a matter of fact, we're doing a special Friday session. We're starting Friday streaming, so starting at 9 o'clock Eastern tomorrow morning, we actually have a special session about how a certain piece of AI technology can help you tackle COVID-19, at least scheduling nurses and doctors who have to deal with the outbreak kind of thing. It'll be a fun session. Come check that out. It's related to artificial intelligence applications that we have been working on, something we've been working on here at Red Hat. But thank you for your time. Look for those emails. Do check out our URLs. Do come back to this URL for the recording, as well as the slides as we get those updated. Thank you so much.